Okay, this is a review of topic 3.13 trigonometry and polar coordinate. So here we are given a polar grid and we need to plot and label the following points on this grid. So 3 comma 2 pi over 3. It's pretty straightforward when both are positive. In fact, in all these questions, both are positive. So both has an R value and theta value. So if they are same, then I don't think so there's any challenge here. For 3, you just have to locate the circle with the radius of 3, which is obviously the outermost. This ring corresponds to r equal to 3, and 2 pi over 3 is the angle. So they have only given the first, the quadrant 1 angles, but we know that 2 pi over 3 is 120 uh, degrees, which will be which has a reference of pi over 3, right? So it will be 2 pi over 3 will be somewhere over here. In fact, not somewhere over here, exactly here. So this is the line that corresponds to 2 pi over 3, and where the red circle and the green line intersect, that is our point. So I'm just going to erase this and plot the point A over here, which is right here. This is the point A. Then we have 2 and 7 pi over 6. 7 pi over 6 is in quadrant 3, right? And 2 is right here. Okay. Now 7 pi over 6, what is the reference? Pi over 6. So this is pi over 6. This one will be 5 pi over 6. And this one over here, right? Because it's, see, the one line in between is left. So likewise, one line in between is left. And this is quadrant 3. So 7 pi over 6 is right here. But this is the angle and this is the line, right? This one. This is the circle of 2. So what is the intersection? Intersection is right here. So this is the point B. So let me mark the point B. It was here and here. This right here is point B. Okay. 1.5 and pi over 4. So 1.5 is definitely between 1 and 2. So this is 1 and this is 2. This is divided into 3 parts. So obviously 1.5 is right in the middle of these two circles. This is 1.5, and pi over 4 is obviously here. So this is the 1.5 circle, and this is the pi over 4. So this point right here is the point C. And finally, 1 comma pi over 2, obviously 1 is right here, pi over 2 is right here. So 1 comma pi over 2 is this one. This is point D. Right, now these questions are going to be interesting because here the R value is negative, right? So if the R values are negative, that's where we have to be a little careful. So let me tell you a trick how to plot these points. Forget about the negative sign, right? Just plot 3, 5 pi over 6. So how will I plot, how will I plot 3? 3 is obviously the outermost ring, and 5 pi over 6, the reference is pi over 6. So 5 pi over 6 is quadrant 2, which is right here. So 3 comma 5 pi over 6 is definitely this point. But since this has a negative r, all you have to do is find a mirror image about it or reflect it just across. What I want to say is the actual point that we have will be on this line right at the opposite end. What is the opposite end across the green line of this red point? Of course, that is this point over here. So this point is A. This is the required point for us. So we plot the point with positive R and then basically just move it straight across 180 degrees. Okay, negative 2 pi. So we'll plot 2 pi. 2 pi, pi is right here. This is pi. And 2 is right here, 2. But we need negative 2. So we just go 180-degree opposite and we will come right here. So this is the point B. Okay. Negative 1 pi over 3. So we plot 1 pi over 3. 1 is here. Pi over 3 is here, right here. But we need negative 1. So we go exactly opposite. So exactly opposite would mean that we are tracing this particular line right here. So this point is the point C. Exactly 180 degrees. Okay. And finally, 3, 7 pi over 4. 7 pi over 4 is in quadrant 2. Sorry, quadrant 4. 7 pi over 4 is right here. That is the reference. So 7 pi over 4 will be 1, 2, 1, 2. So this is the middle line, like 1, 2, 1, 2. This is the middle line. So this is 7 pi over 4. And 3 is obviously this one. But we need to plot negative 3. So all I have to do is trace this over on the other side. So this point is point D. That is the final answer. Right, I hope these make sense. Let's move ahead. Now, this is the third variety where the angles are also negative and R could be positive. And so it's a combination, right? Here you can see that now the angle is negative. So negative angle is definitely not a big thing. All you have, the only change is the negative angles are tracked in a clockwise sense. And positive angles are tracked in counterclockwise sense that we know. That's a convention, right? So if I have a 2, I will still be at the 2 ring, but now I have to start obviously from the x-axis, but in the clockwise sense like this. And I have to go till pi over 6. So this is pi over 6 in the positive side. So obviously this will be pi over 6 when we track in the negative direction of the clockwise sense. So 2 comma pi over 6 or 2 comma negative pi over 6 will be right here. Likewise, we have negative 3, negative pi over 2. So the same strategy, just ignore the negative. So 3 comma negative pi over 2 will be, 3 is obviously here and negative pi over 2 is here because positive pi over 2 is this. So negative pi over 2 is this. But since I have to plot negative 3, so I'll just reflect this across. So this point will now become negative 3, negative pi over 2. I'm sorry, this is B. Okay. Um, Okay, negative 2, 3 pi over 4. Likewise, 2 and 3 pi over 4 is, I think, where's 3 pi over 4? It's in quadrant 4, right? Quadrant 2, right? So this is pi over 4, so this is 3 pi over 4. And this is 2 over here. So this point is 2 and 3 pi over 4. But since we are looking for negative 2, we are just going to reflect this right across, which is right over here. So this point is negative 2 and 3 pi over 4, which is right here. Now finally, negative 2 pi over 3. I ignored negative 2 for the moment. So 2 pi over negative 2 pi over 3. The reference is pi over 3. Pi over 3 is right here. And negative 2 pi over 3 is in a clockwise sense. And we have to go 120 degree in the clockwise sense. So basically it will land in quadrant 3. Quadrant 3 right here. Okay, so this is pi over 3. Then this will be its corresponding quadrant 2 angle. This will be its corresponding quadrant um, 3 angle. And this will be its corresponding quadrant 4 angle, right? So since we are going in quadrant 3, we will land at this point. So negative 2 comma negative 2 pi over 3 will be somewhere over here, right here. But since we are tracking negative 2, so we just have to reflect it across this line and lie somewhere over here, plot somewhere over here. So this is where I have this point, which is point D. All right. The location of a point in the plane is given by this, right? Two different representations for this point in the polar coordinate. Okay, let me brief the theory about this. If r comma theta is a point and I'm looking for three other equivalent representations, so what I usually do is there is one other representation that I can write with the same r, assuming that r is positive. So that will be the same, keeping the same r. And theta is now changed to either plus 2 pi or minus 2 pi, assuming theta is in radians already. Because see, 2 pi is just one complete circle, right? So if a if a polar point is right here, and even if I take one complete rotation and come back, I still lie at the same point. That's why these are equivalent points. And likewise, there will be two other points with r as negative. So it will be negative r, and then with theta, you can add pi to it. because that's what happens, right? If I make r negative, it basically switches 180 degrees or pi. And if I again add pi to the theta, it will again come back to the same point. It's like, double negatives cancel. It's like double, this negative is also moving by pi, this is also moving by pi. So the effect overall is nullified. So that's why these are equivalent points. And finally, with the same r, I can also, rather than adding pi, I can subtract pi as well. That will also give me the same answer. So these are popularly the four forms of writing a single point, or maybe three extra ways to write a single point. I'm keeping in mind that this angle, what we are getting over here, this angle is between 0 and 360 degree, right? If there is no such restriction, then basically there are just infinite ways to do it, because you keep on adding 2 pi, 4 pi, 6 pi, add pi, 8 pi, and it will give you the same situation. And likewise, you keep on adding or subtracting pi, 3 pi, 5 pi, 7 pi, etc., and it is going to give you the same situation. Okay, so keeping these things in mind, I'm gonna rewrite this. This is going to give me 4 comma 5 pi over 6. Now a positive, keeping the positive r, I can rewrite the same point by subtracting 2 pi. I can add 2 pi as well. It doesn't really matter because they have not given us any restriction, right? But I'm just subtracting 2 pi. You can add 2 pi as well. So it will be 6 2s are 12. 5 minus 12 is negative 7. So negative 7 pi over 6. That's one way. And probably the other way, I'm going to write with negative r so that you can see and get a practice of it. Although I can just as easily add 2 pi and get another point, but it's important that you should know how to write this with a negative r. So I'm going to write this with negative, and I'm either going to add a pi or subtract a pi. So let's add a pi. So this will be minus 4 comma 6 plus 5 is 11. So 11 pi over 6. So these are the equivalent points uh, of the given polar coordinate. Okay, let's do the same situation with this one. So negative 3 comma 5 pi over 4. I think first I'm gonna just subtract 2 pi. So that will be the same thing without changing the r. So that's going to give me negative 3 comma 4 times 2 is 8. 5 minus 8 is negative 3. So negative 3 pi over 4. And then I'm gonna change the sign of r to positive, and then I'm gonna subtract pi, or maybe add pi. Let's subtract pi this time. So this will be 3 comma 5 pi minus 4 pi is pi, pi over 4. So these are the two equivalent representations. Same situation over here. So I'm gonna I think add to subtract 2 pi in this case first. So let's subtract 2 pi. So 2 comma 3 pi over 2 minus 2 pi. If we subtract, then 2 times 2 is 4. 3 minus 4 is negative 1. So negative pi over 2. And likewise, from here, I'm going to write one with negative r. So it will be negative r and subtract pi, let's say, or add pi, whichever you feel like. 3 pi minus 2 pi is pi, so it will be pi over 2. So these are the two equivalent forms. Okay. Here we need to figure out which option is correct. So let's see. Obviously not B. I mean, how is B possible? You just change the sign of R without changing the angle. Obviously, this is not an equivalent point. Let's see. If you are changing the value, okay. Let's say I keep the same point. I'm getting a feeling that this is the answer because if I keep the same R, let's say 5, and if I subtract 2 pi, that's one way to rewrite the same point, right? Okay. So this can be written as 3 2s are 6 and 4 minus 6 is negative 2. So yes, indeed, 5 comma negative 2 pi over 3, which is option C. This is the equivalent point. Uh, if I write negative, then either I have to add pi or subtract pi. It's not like you can just add another negative to the angle and it will give you the same point. That doesn't make sense. So I think option C makes logical sense. Likewise, over here, we need to give the other point. So if I keep the negative sign, there's only one option with the negative. I have to add a 2 pi to it. But I don't think so. Pi over 2 and 3 pi over 2, pi over 2 to 3 pi over 2, you will get by adding 2 pi, because the moment you will add 2 pi to it, you will get 5 pi over 2. So definitely not A. Now, switching the sign of R in all these options, if I switch the sign of R, make it positive, then at pi over 2, I can either add pi or subtract pi. Let's subtract pi because I see that two answers are with a negative r. And if I subtract pi, then pi over 2 minus pi is negative pi over 2, which is definitely option D. That's the correct choice. Okay. Likewise over here, there's just one negative option. So I don't know. I feel like maybe the positive would be the answer because there are three choices. They might want to make it a little, you know, complicated. I don't know. Let's find out. So if I change the sign of r from -4 to 4, I have to add pi or subtract pi. I think I'm going to add pi because kind of all are positive, so that's my guess. And 5 pi over 6 plus 6 plus pi, 6 plus 5 is 11, so that will give us 4 comma. Yes, that is definitely matching with option C, so that's the correct choice. Okay. Here we need to convert the polar into rectangular. So I think I talked about this formula early as well, I think in 3.1, but let me give you the formula again. X is equal to r cos theta and y is equal to r sin theta. That's the conversion of rectangular to polar. So x is equal to 2 times cos 5 pi over 3. What is cos 5 pi over 3? If I ignore this, then I'm left with pi over 3, which is 1 over 2, and 5 pi over 3 is in quadrant 4, so it's again positive, so it's again 1 over 2, so 2 times 1 over 2 is just 1. So x is 1, and y is our sine theta, which is 2 sine 5 pi over 3. If I ignore this 5, then sine 5 pi over 3 is sine pi over 3 is root 3 over 2. 5 pi over 3 is in quadrant 4. Quadrant 4, this is negative, so negative root 3 over 2. So the answer is negative root 3. Y is equal to negative root 3. So 1 comma negative root 3 is option C. Over here, I have x is equal to r cos theta once again. So r is 1 and cos of 2 pi over 3. I ignore this 2. So cos pi over 3 is 1 over 2. So 2 pi over 3 is in quadrant 2. This is negative 1 over 2. So answer is negative 1 over 2 for the x coordinate. And for the y coordinate, it's r sine theta. So 1 times sine of 2 pi over 3. So it will be 1 times, and sine of 2 pi over 3 is again, I think sine pi over 3 is root 3 over 2. 2 pi over 3 quadrant 2. Quadrant 2 sine is positive. So that's just root 3 over 2 again. So y is root 3 over 2. So negative 1 over 2, root 3 over 2 is option C. Okay. I think the same situation over here, you can even try it on your own as well. X is equal to r cos theta, so minus 4 times cos pi over 3. Cos pi over 3 is just 1 over 2, that's in quadrant 1. So negative 4 times 1 over 2 is negative 2. And actually the only option with x coordinate negative 2 is option C. So just going to mark that. Okay. The next one is x is equal to r, which is negative 1, cos of negative pi over 6. Negative pi over cos of negative pi over 6. See, negative sign doesn't really change cosine, right? That's just an even function. So it eats the negative sign, it digests the negative sign. So it's as good as cos pi over 6, which is root 3 over 2. So that's going to be negative root 3 over 2, which is option B or D. And y is equal to r sine theta. So negative 1 sine of negative pi over 6. Sine cannot digest the negative sign, it throws it out. So double negative becomes positive. So it's just sine of pi over 6, which is 1 over 2. So answer is option B. Right. Over here, we need to figure out, okay, this is the reverse engineering, right? You have to go from rectangular to polar. So I will give you the formulas. R is root of x square plus y square, and theta uh, depends on the quadrant, but the reference theta formula is tan inverse absolute value of y over x. Now, what is the meaning of this reference theta? I think it will make sense in question 2. So let me solve that question first. Um, so first off, what is r? R is, I think, in this case, root of negative 1 over 2 square, which is 1 over 4, and root 3 over 2 square, which is 3 over 4. 1 over 4 plus 3 over 4 is 4 over 4. 4 over 4 is 1. Square root of 1 is also 1. Now, I'm going to find the reference angle because, okay, you will understand in a minute what I mean from that. I have an absolute value. I have a y coordinate, which is root 3 over 2, and x coordinate, which is negative 1 over 2. So this becomes tan inverse root 3, right? Because 2 and 2 is gone and negative became positive. And tan inverse root 3 is pi over 3. It's in quadrant 1. But this is only the reference angle. I have to figure out the actual angle by plotting this, getting an idea that which quadrant is this point in. And this is in quadrant 2 because x is negative, y is positive. So I have to find what is the equivalent angle of pi over 3 in quadrant 2. And in quadrant 2, it is 2 pi over 3. So this is the angle and this is the r, which is option C. That is how we do it. Okay. Here, it's very straightforward. R is just root of 3 square plus 0 square, which is just 3. And here, actually, 3 comma 0 is like over here, right? It's already in on x-axis. So whatever theta you get, basically theta is just 0, right? Obviously, that's evident. You can even figure it out from here that it will be tan inverse 0 over 3. 0 over 3 is 0, tan inverse 0 is 0. So my answer is just 0. It's a different point that they have not given us that option, but that's fine. Uh, don't you think that, okay, see, my answer is 3 comma 0, right? There's no confusion about that. If you stop looking at the options for a minute, our answer is definitely 3 comma 0. But since the options doesn't include that, all I have to do is follow the same earlier strategy where I can rewrite this I can rewrite this point in a different polar form. So let's replace r with a minus r and let's add a pi to 0. So this is matching, right? So that is the correct choice. Okay. Likewise over here, r comma theta. So r is the square root of, how can, okay, all right, square root of negative root 2 square plus negative root 2 square. 2 plus 2 is 4 because root 2 square is 2, right? 2 plus 2 is 4, 4 root is 2. Okay, and we need to figure out what is the angle now. So angle is reference angle, by the way, is tan inverse absolute value negative root 2 over negative root 2. Negative root 2 over negative root 2 is 1. Tan inverse 1 is pi over 4. Clearly, this is negative negative, so it's in quadrant 3. The equivalent of pi over 4 in quadrant 3 is 5 pi over 4 because it's just like, pi plus pi over 4, which is 5 pi over 4. So our answer is 4. Why have I written 4 here? 4 square root is 2, right? Yep. 2 comma 5 pi over 4, and amazing, that is actually option A. Okay, going to complex world now. Nothing fancy, it's basically just using the concepts of the polar coordinates. A complex number is represented by a point in the complex plane. The complex plane has a rectangular coordinates. Which of the following is a way to represent it in polar form? So all you have to do is find r and theta. Okay, the theta is obviously written in a different way. I'll just tell you in a minute how to write that. Okay, so what is r, guys? R has the same formula, of course. So r is square root of, okay, let me give you the form of the complex number first, the polar form. The polar complex number is usually represented by a z, and its polar form will be given by r cosine theta plus I times r sine theta. And that's how it will make sense. Now the options will make sense. So the r will be square root of 2 square plus negative 2 square, which is 4 plus 4. 4 plus 4 is 8. 8 is 2 root 2. So it has to be either this or this. And the theta reference is tan inverse absolute value negative 2 over 2. So tan inverse 1, which is pi over 4. And positive negative means it is quadrant 4. Quadrant 4, pi over 4 equivalent in quadrant 4 is uh, 7 pi over 4, right? So angle is 7 pi over 4. If you notice, none of the angle is 7 pi over 4, but don't you think that the equivalent form of 7 pi over 4, another way to write 7 pi over 4 is if we just subtract 2 pi from it, which will give me 4 times 2 is 8, 7 minus 8 is negative 1, negative pi over 4, which is right over here. So option C makes the best sense. Likewise over here, let's find the value of r, which is square root of negative root 3 over 2 square plus negative 1 over 2 square. So that's going to be root of 3 over 4 plus 1 over 4. 3 over 4 plus 1 over 4 is 4 over 4. 4 over 4 is 1. Root 1 is just 1. So it cannot be D. Angle will be in quadrant 3, of course. I can say it right off the bat. It cannot be option A because 5 pi over 6 is in quadrant 2. Let's find the angle now. So the reference angle is tan inverse absolute value of y coordinate over the x coordinate. So this is tan inverse 1 over root 3, which is pi over 6. And pi over 6 in quadrant 3 will be 7 pi over 6, which is clearly option B. All right. Over here, this is pretty straightforward. You just have to simplify this and write this in the rectangular form. So what is cos negative pi over 3? We just learned that cos eats the negative sign. So cos pi over 3 is 1 over 2. 2 times 1 over 2 is 1. And I times here, sine will throw the negative sign outside. So negative 2, and sine pi over 3 is root 3 over 2. So 2 and 2 is gone, and it will be 1 minus root 3i, which means that the coordinates are 1, this is the x, and negative root 3, this is the y, which is option B. Likewise, cos 5 pi over 4, I ignore the 5, so cos pi over 4 is root 2 over 2, and 5 pi over 4 is in quadrant 3. In quadrant 3, cos is negative, so negative root 2 over 2 is the x coordinate, and the y coordinate is likewise sine pi over 4 is also root 2 over 2, and sine in quadrant 3 is also negative, so actually they are just same. So this comes out as 2 times 5 is 10, so minus 5 root 2, minus 5 root 2, which is option A.